Step number 1, factorize. Step number 2, find the limits. The limits means just solve it as normal, but you don't actually say these are your answers. These are called the limits. Okay, these are called the limits. They're your limits. Once you do find your limits, number 3, sketch graph. Okay, and the sketching of a graph is a skill of itself. There, you draw this, -2 goes there, 3 goes there, and then you decide on the shape. Okay, you decide on the shape. So decide shape. So if you got an x squared, then it's going to be a positive graph. If you've got a negative x squared, then it's going to be a upside down graph. All right. So here, can you see you got an x squared, a positive x squared. So your graph is going to look like that. All right. Your graph is going to look like that. Okay. That's number 3. Step number 4, after you've done that, is you need to go back to the original thing and you're looking for where the y, if it's less than 0 or y is greater than 0. That's what you're looking for. And you just go back up to the original thing up here and see this. So this is going to be equal to y, because any equation, x squared plus equals to y. So your one, you have this less than 0. So here you have less than 0. If it's less than 0, if you go to any graph, this is your y-axis, right? These are the values of y. Along here, you have the values of y. All of the y values here are positive. All of the y values under here are negative. So less than 0 would mean it's below this axis here. It's below that. So here, I will go here and highlight it. It's this part of the graph I'm interested in. All right, because this part is above 0. All right, we'll look at an example of this next, where we have this. Okay, so because it's continuous between those 3 and -2, we just say x, our answer, is less than 3 and greater than -2. And that is the answer, the solutions to this inequality. Okay, for this inequality to exist, the values of x must be greater than -2 and less than 3. All right. Now, I'm just going to quickly show you what would have happened if it was another type of graph. Okay. I'll actually use the same equation, x squared minus x minus 6, but I'm going to do greater than 0. Can you see? I've changed the sign. Okay. It's greater than 0. Now, I'm going to do. Okay. Now, I'm going to do step number 1, factorize as normal. I'm going to do finding the limits, and I'm going to sketch the graph. Okay. I'm going to do all of that the same. So that is basically this graph right here. Okay. So I'm going to just do that all over again. But obviously, I've done it up there, so I don't need to repeat stuff there. However, this time, it's y is greater than 0. So the y values greater than 0 are up here. So it means this part of the graph here and this part of the graph here is what I want. So I'm just going to label it here. Now watch this. This is the one that people normally struggle a little bit with, okay? This part of the graph is when the values of x are greater than 3. Yeah, so look, for example, like 4 will go up there and give me a value here. Give me a value of y, which is greater than 0. Likewise, on this side here, these part, like anything less than or smaller than -2 also gives me values of y that will hit that graph here and give me y values greater than 0. So for this particular part, if it was greater than 0, the same equation, I want this part of the graph and that part of the graph, which means I want values of x which are greater than 3, or, so it's not continuous, or x values less than -2. You see, I've got two different inequalities here. And that's how you do that. All right. Now there's one more just to give you a comprehensive thing. If I have a negative x value, you can start on whichever one is less than a half or x is greater than 4. And they are your inequalities. And that is how you do the quadratic inequalities. Any questions?